Good morning. Uh, we'll continue the lecture on projection of planes. So a plane, the first position, you will get uh, different types of problems in projection of planes, where we have to draw the projections of the planes in different positions. Okay. The first position I have already told you, when the plane is resting on HP on one of its sides. So the most important point here is you have to draw the initial position correctly. So as I said, initial position, you have to imagine the plane to be completely resting on HP, and the edge on which it is resting on HP must be perpendicular to PP. So this is the edge. Last class I have shown you this. Yeah. So this is the AC is the edge on which the plane is resting on HP, and it should be perpendicular to VP. So when you draw the initial position, as I said, this is the XY line, and the initial position will be like this. So this is A, B and C. AC is the edge on which it is resting on HP. So then this is the top view, and in the front view it appears as a line on the XY line. So this is A dash, B dash, which are visible if you are looking from here, and C dash is invisible because it is behind A. So similarly, I told you, if it is a square lamina, so the initial position will be like this. So this is A, B, C, D, the top view, and the front view will be this. It will be a line on the XY line. So this is A dash, B dash, C dash in brackets, D dash in brackets. As you can see, C is behind B, A is behind, D is behind A. So they are hidden. So whatever points which are hidden, they will be in brackets. Okay. So similarly, if you have a pentagonal lamina, okay, so this will be the initial position which you have to draw. So this will be the edge which is resting on HP. Okay, A, B, C, D, E. So AE is the edge which is resting on HP. So draw the front view. So front view will be on the XY line. So this point is A dash, which is visible to you from here. Okay, and this is B dash, and this is C dash. So this will be the front view of the lamina which is resting on HP, completely resting on HP with one of the edges perpendicular to VP. So this will be the initial position of a lamina which is resting on HP on one of the edges. So the hidden points, D is hidden here, D dash, and E is hidden here, E dash. So this will be the initial position of the pentagonal lamina which is resting on HP. So if it is a hexagonal lamina, so as I have shown you in the previous lecture, this is how it will be. So this is A, B, C, D, E and F. The front view will be on the XY line. So please you draw it to scale, and this is also given in the notes which I have sent to you. So if you look from here, the corners A, B and C are visible. Therefore A dash, B dash and C dash will be visible, and D dash will be invisible, E dash will be invisible, F dash will be invisible. So this is the initial positions of the lamina which is resting on HP on one of the sides or edges. Now last class I have shown you, in the first lecture I have shown you how to draw the projections of a lamina which is resting on HP on one of its sides, the surface is inclined to HP, and the edge on which it is resting on HP is inclined to VP. Now in this class, what we'll do is, there is one more type of problems which we'll get, wherein he says the perpendicular bisector of the edge on which is resting on HP, that is this line, the perpendicular bisector of the edge, this is the edge, AC is the edge which is resting on HP. Okay, so this is inclined to VP. So in this case, the solution is a bit different. So what you have to do is, the initial position will be same, and the HP condition also will be same as what I have shown you before. So the problem will be like this. He'll say draw the projections of the lamina equilateral triangular lamina. Resting on one of its sides on HP, surface is inclined to HP at 40 degrees, and the perpendicular bisector of the edge is inclined to VP at 30 degrees, for example. So this is the type of problems you'll get. So this will be only for triangular lamina and pentagonal lamina. So in case of triangular lamina, this is how the lamina looks. So it is resting on HP on its edge. The surface is inclined to HP, and the perpendicular bisector of the edge on which it is resting on HP is inclined to VP. Now in this position it is parallel to VP. So you have to rotate it like this, or you can rotate it like this. Okay. So how to draw I'll teach you how to draw the projections of such a lamina. Okay. So initial position will be same. So this will be the initial position. Assume the lamina to be completely resting on HP, so that the edge on which it is resting on HP must be perpendicular to VP. So we'll draw the XY line. This is the XY line. Then top view, initial position in the top view, it will be a equilateral triangular lamina like this, so that this is A, B and C. This is the edge on which it is resting. It is perpendicular to VP, as you can see. Now there is a perpendicular bisector of the edge AC is this. This will be the perpendicular bisector of the edge. So we'll call this as, say, M. It starts from the midpoint of AC. Okay. Now project the front view. Front view will be a line on the XY line, as you can see. It will be a line on the XY line. So draw projectors from C and B, and you draw the front view. In the front view you will see a line. So this will be A dash, this will be B dash, and this will be C dash. Now next is the HP condition. The surface is inclined to HP at 40 degrees. So always the edge AC should always be on the XY line. So this is A dash and C dash. Now draw a line inclined at 40 degrees to the XY line. Draw a line inclined at 40 degrees to the XY line. The length of this line must be equal to the length of A dash and B dash. So measure A dash and B dash and mark it here. So this will be the new front view of the lamina, which is inclined to HP at 40 degrees. So this is called as the HP condition. This is called as the initial position. Okay, now project the top view. So draw the projectors from here. Vertical projector, and from the previous A draw a horizontal projector. This will be A and this will be C, and draw the projector from B, and from the previous top view draw the horizontal projector. Join AB and C. Join AB and C. This will be the second top view. That is the HP condition. Now here this will be your M. Okay, so here M also is invisible. Okay, now you can see that the length of M and B, the length of MB here has reduced because the lamina is now inclined to HP. So earlier it was like this, so you are seeing the true length of the perpendicular bisector. Now the lamina is inclined, therefore a shorter length will be seen. So that is what is seen here. Now the first two sets of figures will be similar to what we have done in the previous class or previous lecture. Now he says this perpendicular bisector is inclined to VP at 30 degrees. So inclination to VP at 30 degrees means it is the true inclination. So draw a line inclined to VP at 30 degrees. Draw a line inclined to VP at 30 degrees. Now because this is true inclination with VP, you have to take the true length of the perpendicular bisector. So MB is the true length of the perpendicular bisector. So this, from this figure you take the true length of the perpendicular bisector. So measure this and mark it on this line. So this is the true length, okay, of the perpendicular bisector and true inclination with VP. And as I said, because the perpendicular bisector is already inclined to HP, then now it is also inclined to VP. So if a line, as you know, if a line is inclined to both HP and VP, it will not be seen in the true length or true inclination either in the front view or in the top view. So what we have to do, we have to find the apparent inclination of this perpendicular bisector. So this is the true inclination, okay, and we have to find the apparent inclination of the perpendicular bisector so that we can draw the projection. Now how to find the apparent inclination? As you can remember, in projection of lines, what we have done, we have drawn the locus of B. We can call it as locus of M or locus of B here, locus of B. Okay, so this is locus of B. So if you don't remember, please go through what we have done in projection of lines. Next, this is the true length and this is the apparent length of the perpendicular bisector. So take the apparent length from here, this figure, this length from M to B. It is smaller than the true length. So take this length, apparent length, and then from this point, suppose this is M, okay, from M you draw, you cut the locus, okay, you take MB as, this MB as radius and cut the locus which you have drawn, locus of B. So the point at which it cuts, that will be the new view, okay. So if you join this, you can see the length is reduced, okay, and if you measure this angle, this will be your beta angle. You have to measure it, okay. Now next is what you have to do, you have to draw this top view in this position. Okay, so how to draw this top view in this position? You know MB, this line is perpendicular to AC. So you have the line MB, draw a line perpendicular to MB passing through M. Okay, next measure MA and MC. They are same because M is the midpoint of A and C. So measure MA. Okay, and from here you from midpoint, from this M, you cut the line, perpendicular line which you have drawn to MB. So this will become your point A, and on the other side you cut with the same radius, you cut this will become your point C. Now join A, B and C. Okay, so this will be the new top view in the VP condition, whatever he has given in the problem. So this is the VP condition. Now project the front view. As I said, it is very easy to project the front view. From all the corners, draw perpendicular projectors. Okay, you know in the front view A and C are on the XY line. So from A, draw the projector to cut the XY line. So this will be the new front view A dash, and from C also you draw a perpendicular projector. So this will be your new C dash. Then from B, draw a perpendicular line projector. Okay, then from the previous front view of B, that is B dash, draw a horizontal projector to cut it. So this will be the new front view of B. So join A, B and C. This will complete the problem. Okay, so similarly, if you have a pentagonal lamina, okay, you have to follow the same procedure for drawing the projections of the lamina, which is resting on HP on edge. Okay, the surface is inclined to HP and the perpendicular bisector of the edge on which it is resting on HP is inclined to VP. So in this position, the initial position, the perpendicular bisector will be parallel to VP. Then in the problem he is given, the VP condition is it is inclined to VP at 30 degrees. So I hope you can solve the problem which I have given in the notes. Okay, so solve this. In the next lecture I will tell you about how to draw the projections of a lamina which is resting on VP on one of the sides or edges. Thank you.